Good afternoon and good evening, folks. Chief Meteorologist Nick Lilia here in the Severe Weather Forecast Center back in behind the set. You can see it over my left shoulder there. We're taking a look at the severe weather threat for this weekend. We've got a lot to get to, and I'm going to dive right in. To grab your attention, first things first, we're going to start off at about noon or so tomorrow. And you can see that we do have showers and thunderstorms approaching the area, says the RPM that we're looking at here from WSI, just off to the west. We've got round one, and we've got round two. And if I push this forward, I haven't looked at this model quite yet, but if we push this forward, I bet you we get round three. So we got all these showers and thunderstorms move through. Now this is 7 o'clock at night, so they push through. We still have isolated showers and thunderstorms across the area, kind of here and there. And this is where we're concerned about the severe weather actually happening, is in these discrete isolated cells pushing across the area. We're concerned about heavy rain, but I'm actually more concerned about round two. And here we go all the way through midnight, and this is where I'm concerned most about the flooding, is round two that rolls on through, or round three, depending on how you look at it. By around midnight or so and into the overnight hours, we could see rainfall rates in this line right here between 1 to 2, perhaps even 3 inches per hour, given how much water and how much moisture is going to be available in the atmosphere. We'll push this forward till about 7 a.m. or so, push it back a little bit, and notice we still have showers and thunderstorms mainly across some of our southern zones, and all the way through 7 o'clock on Sunday morning, and then by the time we get into the afternoon, we get the all clear. So I'm going to run this back. We're going to look at this one more time here in a second, but I'm going to bring us all the way back to 18Z here. You can see that down on the bottom, roughly lunch or so tomorrow. Okay, now that we've taken a look at the radar, I've given you some timing on the rain, the showers, the thunderstorm activity. Let's take a look at why we're concerned about severe weather, and we're going to start this off with the SPC. I do want to show the categorical, there we go, marginal risk for tomorrow, and then the slight risk underneath it. And I know you're thinking going slight, that doesn't sound too bad, but keep in mind with the SPC, we're working on a 1 to 5 scale that goes from marginal, slight, enhanced, moderate, and high. So anytime you get a slight, that's 2 out of 5. So that's not exactly 0, and that's not, I don't think, necessarily a slight chance. A 2 out of 5 usually means around here, if you've got a slight risk, you're going to see at least 1 or 2 warnings, be it tornado, severe thunderstorm, or maybe even flash flood, given how much rain we're looking at over the next couple of days. But let's start from the top and work our way down. There's your area of low pressure. Here we are at 300 millibars or so. That's about 30,000 feet, about where planes fly up in the atmosphere. So there's our area of low pressure right there. We're taking the winds, we're sweeping them down around the bottom side of that low and then kicking them back off to the east and northeast. And, well, maybe more of a northeasterly and maybe more of an easterly kick right there. But there's our area of low pressure aloft, and again, this is way up in the atmosphere. Pretty deep low up there. It's really not too bad, not too shabby. The wind's coming around this bad boy. That's 120 knots, 100 knots, 70 knots, and again, this is up pretty high, so we don't have to worry about winds like that down here at the surface. But we'll bring it down a little bit closer. Here we are at 500 millibars, and this is where we start to look at the winds in terms of supercells around here to see if we can't start stacking some of the winds from the surface all the way up on top of each other and shifting them from one direction to another to give us an opportunity for some severe weather. And right now, most of these barbs have it coming out of, I'd say, almost west, maybe a little southwesterly. And then there's our area of low pressure there. We got the front that kicks off down to the south. What we're looking at the surface, and again, I want to go back here. We got this area of high pressure over here, area of low pressure over here. Now, we all know that high pressure goes to low pressure. That goes for everything. That's why when you go into one of those tennis blimp things, you know, where they make the bubble on the ground and people play tennis inside, you know, they're filling that up with air, so when you open the door, all the air hits you right in the face. High pressure in there, low pressure outside. Same idea, high pressure in the Gulf, low pressure in Texas, which is why we're going to have winds out of the southeast pretty good for tomorrow. 5 to 15, probably a couple of gusts to 20. All right, so let's bring it back down to 7,000, or 7,000, how about 700 millibars, or about 10,000 feet or so. And now our winds are coming back out of the south and west. And I'm gonna back this up a little bit. We're gonna follow the barbs here, and you're gonna see what I'm talking about with this rotating wind. So we've got winds out of the west-southwest, west-southwest, out of the southwest. As we bring it down to 850 millibars or so, that's about 4,000 or 5,000 feet. Now we're back out of the south-southwest, and as we bring it down to 925, now we're back out of the southeast. So you see that as we move up in the atmosphere, 925, again, the numbers work backwards when you're talking about millibars because it's pressure, it's air pressure. Down here at the surface, coming out of the southeast, as you work your way up, that southeast wind actually shifts back around and eventually comes back out of the south and west. And what you do with that, if you've got, let's say you've got your thunderstorm over here, we'll make a little thunderstorm cloud, there you go. If you've got winds out of the southeast here, but it's out of the southwest over here, you can take everything from the surface, all that moisture, warm, moist air, you can bring it in, kick it up, and then move it out. And you create kind of a conveyor belt in there, and it allows also for some of these storms to begin to rotate. Now that's the storm, we're not talking about tornadoes yet, just the storm itself to start to rotate, and this conveyor belt keeps these thunderstorms alive. A lot of times in the summer, we talk about thunderstorms, we'll make a little thunderstorm cloud again, and they'll rain themselves out, we say. So it rains, it's trying to take that warm air and move it up to make a cloud, and then it's raining cold air, cold rain, right in the place that it's trying to get the warm air from. And the cold air wins. In this case, we're making that same thunderstorm, but instead, what we're doing is we're taking the warm air in from one direction and we're pushing the cold air out somewhere else because of the winds that we have aloft. So that's why in the winter, when we get to winter severe weather season or spring severe weather season, that's why those storms are so much stronger than the ones in the summer. The ones in the summer could get that strong if they had the support, but they always rain themselves out too fast, which is why in the summer you end up with a severe thunderstorm warning. It lasts for 30 minutes, 45 minutes, and then it's canceled and the storm goes away, where in the winter and in the spring, these storms last for a very, very long time. You see that line of thunderstorms, or that one cell that holds together for an hour or 2 hours, sometimes 3 or 4 hours. In the event of some very serious thunderstorms, 6, 7, 8 hours. So that's why. It creates this little conveyor belt. In with the warm, out with the cold. It puts these two things in two separate places, and it's able to stay alive a little bit longer. So let's talk about 500 millar vorticity, relative vorticity. Anytime you find the max vort, you head off to the south and east. That's usually where the party's at, and that's where we are. So we've got the upper level support for it. In terms of vertical velocity, now this is, do parcels of air, do they want to go up or do they want to go down? Generally speaking, are they inclined to move upward or are they inclined to go downward? And the upward area is actually a little farther off to the north, which is good for us in terms of our severe weather threat. It mitigates it a little bit. It helps to kind of keep it down. That most of the vertical velocity is well off to the north, and down around here, there's not quite as much. Now, the reason that there's not quite as much, we'll bring it back to the 300 millibars up aloft, pretty high, 30,000 feet. Usually, we talk about these lines in here, we want them to spread out as you move out ahead of this. So you got your area of low pressure here. Most times, they're pretty skinny, just south of the low, but as you get out ahead of it, in the front right and front left quadrant is what we call them, these lines start to spread out a little bit, and as these lines spread out a little bit, you're easing the pressure, and that allows things at the surface to move up a little bit easier, because you get stuff at the surface, high pressure, you got lower pressure aloft. Remember, again, high pressure always goes toward low pressure, whether it's at the ground going to low pressure or high pressure, low pressure. How about things at the surface? If there's lower pressure aloft, they want to move up. And so if you're down at the surface and you're pumping in all this moisture, and then you're looking aloft and you've got lower pressure, you're going to take everything to the surface, you're going to move it up, and you're going to be easily make some clouds, showers, and thunderstorms. Vertical velocity, a measure of that, let's go find it again. The most of it will be off to our north, so we don't necessarily have too much down here. In terms of instability, now historically around here, you want to get above about 500 joules per kilogram in order to start talking about the opportunity for any kind of severe weather. Right now, that 500 line, and again, joules per kilogram, don't really, let's catch up the right line. Don't really worry about the math in there. all you really need to worry about is the number 500, and anything to the south and west of the line that I've drawn on the map here is above 500. And I want you to pay close attention to this. I'm going to go back to what the SPC is talking about. Now the lines aren't going to match up perfectly like on our twister data lines, where I can kind of bounce back and forth and it stays on the same map. It's going to look a little different, so kind of take a picture of this in your mind. I'm going to take off the line, remember kind of where that is, and now look and see all that slight risk almost in the same place. So the SPC is saying, okay, we're going to have kind of enough instability in this area to start talking about the opportunity for more organized severe weather. And my guess would be probably a 2 or 5% tornado risk in there as well. We'll get to that here in a second. So back to the vertical velocity, back to the Cape here, the instability. So our line's about right there or so. And then anytime you get above 750, you're looking pretty good. I will say this, in the last couple of days, most of the models have hedged back a little bit on our instability, but this is the North American model that we're using for this discussion. But I will say that the European, the American, the SHREF, the short-range guide that we use, are kind of all over the map, and it's all a matter of that push that we're going to get from that high pressure. Again, high pressure down here, low pressure here, so at the surface, it's all a question of the push that we're going to get of warm air at the surface. Are we going to get enough warm air at the surface, or sunshine? If we clear out the clouds tomorrow morning, do we get enough sunshine heating to really bump that instability? And if we do, if for whatever reason, instead of 500 to here, this 750 line gets shoved off to the north and east a little bit, then we start to get more concerned about severe weather. A lot of you that watch a lot of these videos remember last year in Colombia, that was the mitigating factor. We were waiting. We were saying, well, we don't know how much instability we're going to have. The more instability, the stronger some of these severe storms will be. We're in the same boat again. We're waiting to see the instability. The shear is there, 30 to 45 or so knots of shear between the surface and about 6 kilometers or so. That's ample for around here. 0 to 3K is about the same. Most of our shear for tomorrow is going to be at the lowest levels of the atmosphere, which isn't necessarily a good thing for us, because it's at the lowest levels that you need the most shear in order to get a lot of our pretty weak tornadoes around here. EHI, a measure of not only instability but also accounts for shear. Anytime you get above 1, that's when you start to talk about the opportunity for tornadoes. Anything below 1 that does also come up and register on here, you're talking about the opportunity to be able to build a supercell. And the 1 is the green in here, and most of it is back off to our west. But notice, that little line right there or so. You could argue that tomorrow, chances are, you'll probably get a 2% tornado risk there, and probably a 5% or so, somewhere there or so from the SPC. But again, that's still about 24 hours away. Helicity, and this is the 0 to 1 kilometer, about 1,000 meters up from the surface, about 3,000 feet. Anytime we look at this, if you can get above 100 around here, you usually have an okay shot to get a tornado. Anything below 100, and we're not even concerned about tornadoes. But anytime above 100, we start to get concerned. Above 200, yeah, there's probably enough spin. If you can get an updraft, you can get enough instability and an updraft stable enough, you'll probably be able to get one. I will say this, at 100 here, just like with instability, we've been talking, that we were just talking about, we've been looking at some of the other models, and as recently as yesterday afternoon, this 100 to 200 range instead was up around 300 to 400 or so. So with each new model that comes out, we get new data in. The newest model isn't always the most reliable, it's just the newest data. So what we'll do is a lot of times we look at a lot of these models and we'll average them between a couple of them. We'll take in some newer data, maybe keep some of the old stuff if we think it's a little more reliable, and that's based on historic records, kind of a gut feeling between the forecasters down here and everything. But nevertheless, I would not be surprised tomorrow if we actually saw some values a little bit higher than 200 in terms of helicity. Now, it depends on which model you look at, but again, that's kind of what we're looking at. And the time frame for all of these, by the way, is tomorrow about mid-afternoon or so, between about 3 and 5, which is when we're looking at all of these, which is when, again, I'll bring it back to here, which is when our first storms really start around noon Here we go to about 3 or 4 in the afternoon. Although I will say this, I always tell folks I'm not concerned about the big glob. The big glob's full of rain. I'm more concerned about these individual little cells that try to develop. And the RPM, spatially at least, isn't quite good enough to pick up where these one individual storms will be. So kind of take this map with a grain of salt here about where the little individual guys are going to be. But it does an okay job with the globs. And again, globs don't really bother me. I do worry about flooding underneath these, given how much moisture we have available in the atmosphere, and I'll get to that here in a second. But the globs aren't bothering me for the tornado threat. It's the individual ones, and I'll bring this through 7 o'clock at night. And again, here we go. And we're still talking about individual cells out ahead of the next glob hanging out with us through the day. So if you do have plans tomorrow, make sure you've got a plan to have a NOAA weather radio handy. I'm going to go back to Twister Day. I'm going to pull up one more thing here, and this is the precipitable water. This is how much moisture is available for us, basically, to create showers and thunderstorms. And on here, anytime you get into purple, right, that's when you start to talk about above 2. Now, around here, in October, November, a PWAD is what we call that for short. I mean, anytime you get a PWAD above about 1, you're probably making some pretty good thunderstorms. You're probably making some pretty good rain. A gully washer, so to speak, probably starts at 1.25 or so. Anytime you get up around 2, you start talking about a lot of water, a lot of rain, some very heavy rain that can fall out of some of these thunderstorms. And that's just where red turns to purple. Now, so we got different shades of purple underneath here. I've actually got to scroll up 2.5. The European model, for example, here we go, I'll go 2.5 there. That's pretty good. The European model that we look at, I was just looking at this before making this video, headed all the way up to 2.75. The National Weather Service in Jackson was mentioning earlier this morning that we could have PWAT values 3 standard deviations above the mean, so 3 times your normal value for showers and thunderstorms, available for those showers and thunderstorms. So we could be looking at some very proficient rainmakers. And to see evidence of that, if you're watching this on Friday at about 3, 4, 5, 6 o'clock at night, just look at what happened in Texas today when they got 3, 4, 5, 6, 7 inches of rain in an hour. Not in a day, not in an event, in an hour. Now, we picked up 7 inches of rain through that whole event this last weekend. Imagine getting that in 1 hour. Now, theirs were a little higher, a different scenario. Topography helps with them to get all of that rain out. But nevertheless, a possibility for sure. And the SREF, this is our short-range guy, the SREF, not really sold on how much rain we're going to get by the time it's all said and done, anywhere between 1 inch to 2.5 inches. I'm more concerned about 1 to 4, locally 4 inches, 1 to 3 for a lot of us. But 4 inches, you can't rule that out. But flooding is really the main concern, and the reason that I'm more concerned about that and less concerned about the severe weather threat. Let me zoom this up here for you guys so you guys can still see that. Now, if you pay close attention to a lot of these videos, you'll remember this little piece of information. Let's see how I can point at it correctly. Up here. And this is the little severe weather worksheet that I like to go through, all of the little algorithms and everything. And the GFS, the NAM, the Euro, the RAP, don't pay attention to that. This is actually old data from our last one. I'll go ahead and make that a whole lot smaller so you don't get confused by that. And then the SREF. But most of these have our 500 millibar temperature up around 6 or 7 degrees below zero, and down here at 850 between 15 and 17 with the dew point right about 15 degrees or so. Cape, the instability between all of these, between 500 and 1,000, I think the Euro is probably the most bullish with our opportunity for instability. And if we get that, then we'll probably have to be concerned about 1 or 2 tornadoes around here. But I think around 500 or 700, while we do have to be concerned about an isolated one, I think that it's going to be, the threat is going to be so isolated that I don't want folks to kind of freak out. We're not talking about widespread tornadoes here. It would be like one, maybe a second one. Your EHI is on here as well. Now, Once we get all that information in here, again, all of these parameters, wind, temperature, wind direction, based on your compass, out of 200 degrees, 210 degrees, we end up with a sweat, total, totals, K-index, and the BRN, and we're able to use these things together in conjunction with what the SPC is thinking, in conjunction with everything that you just saw, to come up with a what are we worried about kind of a factor. And anytime you get that sweat above 400, again, you've got the possibility to make a tornado, and the GFS has us under, NAM has us over, so does the Euro. Again, don't pay attention to the RAP. I'll turn that down so you don't see it. The SREF, not so much. So, two out of 4, so 50-50 shot that one parameter is high enough. Your totals hanging out in the upper 40s and low 50s. That really means that we're likely going to see thunderstorms, but notice that in order to get severe storms out of this one parameter, you really have to be above 50, and we've got one, the European, that suggests that. So now you go down to the K-index, and we're in the mid to upper 30s, the SRF coming in at a 28, mid to upper 30s, moderate convective potential. So you've got the potential with this one parameter to get yourself some decent convection. Anytime you get above 40, that's high. We don't have above 40. And then the BRN, anytime you're in the teens, that's really where you want to be for shear, and that's a measure of shear, wind direction, speed, etc. And that's when we were talking about supercells. Anytime you're in the teens, you're looking pretty good. The SRF is really the only one close. The rest of them either right around 10 or right around 20. So we take all of that into account with everything that you've just seen, and that's why I'm more concerned about flooding than I am wind and tornadoes right now. I think we'll see a couple of severe storms. I think we'll probably see a couple of severe thunderstorm warnings, perhaps even a tornado warning, but right now I'm not necessarily too concerned about widespread severe weather. Another thing to note before I let you guys free, the STP, SCP, mixed layer cape, effective shear, helicity, and our LCLs, that's just the base of the clouds. This is actually taken from the Tornado Environment Browser. We look back in time at all of the tornadoes that have ever been across the Pine Belt, and we get a historical average that you can see on there, and then we compare that against the parameters that are being kicked out by our short range, the SREF model, which is an okay job in terms of a 24 to 36 hour forecast. And you say there's your historical average on there, and are we between it? Yes, 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 no, yes, and yes, in terms of getting a single tornado. So again, I don't want people to think that there's a big tornado threat for tomorrow, because frankly there isn't. But we could have an isolated tornado kind of here or there. My main concern, I really want to drive this home, flooding can do just as much damage as a tornado if you are in the wrong place at the wrong time. So if you come across roads that are covered in water, turn around, don't drown. There was a great tweet earlier from Sean Breslin. He said, there's a life hack for you. There is another way to get where you're going without going through the water. You can take another route. I promise you can do it. And it might take you a little bit longer, but I would rather you drive around than get swept away by some water. So again, flooding can do just as much damage if you're in the wrong place at the wrong time. If you live in a place where you usually see a little bit of flooding, chances are you'll probably get a little bit of flooding this go around for sure, especially if you end up underneath one of these heavier thunderstorms. And again, hail, not terribly too concerned. You might get some gusty winds out of some of these storms, or if a line develops and you get a bow out in front of it, you might get 40, 45, 50 mile an hour winds. You might get a couple of gusts to around 60, but truly the main concern is for rain, heavy rain, perhaps some flooding, and we can't rule out the possibility for an isolated tornado. So that's the breakdown right now as it sits. We'll have more information coming up tonight, 5, 6, 6:30, and 10. We'll get a special video on WDAM.com. And by the way, you can find us on Facebook and Twitter. Patrick will be here all weekend. Rex will be here all weekend. And I will be here all weekend to keep an eye on everything to keep you folks at home safe. If you have any questions, find us on Facebook or Twitter, find us on the website, or you can always shoot us an email.